Hello. Hi everyone. Good afternoon. Am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
Good afternoon, ma'am.
Yes, ma'am. Good afternoon, ma'am.
Good afternoon everyone. How are you all?
Good afternoon. Fine, ma'am.
Fine, ma'am.
Okay. Yeah, thank you for joining everyone. So today and tomorrow we are going to discuss on SOC design. So you will be getting a great insights into the SOC design. Now, what is the processor design and processor verification? What is the difference between SOC, IP, and subsystem level verification? So we will be starting the session in next 1 minute. Okay. Meanwhile, are you all from undergraduate or anyone from working professionals or looking for the job? Quick introduce about yourself in 2 minutes so that we can start.
Undergraduate, ma'am.
Okay, you are all undergraduate.
I'm a student.
I'm working in cadence.
Okay, okay. My voice is audible properly? Is there any noise or disturbance from my side?
Not good.
This product, ma'am.
So it is good, huh?
No, ma'am.
No, ma'am.
Disturbance is there.
There's
I
noise.
can't hear
ma'am. There's
And
disturbance.
also, I am a MTech graduate. I am looking for a job, ma'am. Your background is very noisy, ma'am.
Okay, okay. Is it okay now, everyone?
No, ma'am.
No, ma'am.
Now?
There's still noise.
Okay.
Some disturbance coming at your end.
It's not my end actually. It's some of your end. Let me mute everyone. So whatever the doubts you have, if you want to talk something, then you can unmute your system and you can talk. Okay.
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 And also everyone, please mute. Okay. So a very good afternoon to everyone. Thank you for joining this workshop. Okay, so let's start our introduction. So what we are exactly going to discuss in these 2 days and how it will be helpful for you, and what if you have any doubts in your career path, or if you are facing some confusion regarding your VLSI career, whether to choose front-end domain or back-end domain, every doubt you can clarify in this 2-day session. Okay, and also the main intention of this 2-day session is to give more clarity for the freshers, regarding the what exactly need to learn to crack the VLSI interviews, and what are the major projects required to learn, and what are the major protocols we need to focus. Okay, that's where actually freshers are lagging. From last 2 months we are getting lot of resumes, and we are sending to the client interview, even freshers and experienced resumes also, but still most of the students are not able to crack the interview. Why? Because they are lagging in protocols and projects mostly. Okay, so this 2-day session is mainly overview of SOC, what exactly we need to learn in SOC, what are the different types of protocols out there, and what are the different types of projects can do from fresher side and also from experienced people. Okay, so let's discuss these things today. And I think some of the people, regular students are there from design verification batches, right? So these 2 sessions also will be helpful for you. The introduction sessions of protocols and projects. From next week onwards we are going to start the projects in depth. I will be explaining those things also in the session. Okay, so I think most of the students are interested to learn something from ProV logic. Okay, so let's start the session. I think mostly this will be helpful for freshers mainly. Just for more clarification, we have just planned this 2-day session. Okay, so I think everyone know about the ProV logic. Most of the people are following ProV logic, right? Maybe I don't need to explain especially about ProV logic again. And also me, Prasanthi, Chanda. I think everyone know right? So quickly start with the session agenda. So what is the main agenda of this today's session is, first of all, we are going to discuss about the VLSI front end versus back end. What exactly front end we do and what exactly in back end we do. And what are the different types of system on chip designs we have, IPs, and what is meant by subsystems, and what are the different types of functional blocks available in SOC. And we will be discussing more detail into the processor verification and RTL design. And tomorrow we are mainly focusing into verification role in the industry. What is meant by functional verification, formal verification, testing in backend. We are discussing different roles of VLSI and majorly into protocols and projects. What is meant by a protocol? What are the different types of protocols out there? What are the major interview questions asked for the protocols? And a fresher where need to start and what need to learn and how to learn the concepts of every protocol. Tomorrow we are going to discuss that. Okay, so if you are feeling interested of today's session, you can continue with the tomorrow session with the same link at same time, 2 o'clock. Okay, is that clear, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, it is.
Okay, so let me ask a question for you. Can anyone tell what is the difference between VLSI front end domain and back end?
It is RTL design. The front end is RTL design.
In the
then,
front end,
it's verification and the synthesis till synthesis. Then DFT comes. Then after that PD, which is a part of backend. Then physical verification.
Okay, okay,
at
good.
the ma'am, at the end of front end side, we can deal with the soft part of the designing, and at the back end side, we are dealing with the hardware implementation.
Okay, so how you're going to generate that software copy, soft copy?
Ma'am, using RTL, and we are generate a netlist file,
Mm, okay.
and this netlist file pass to the PD side
Mm, mm.
and backend side.
Okay, okay. So first of all, what is meant by VLSI means it's a very large scale integrated circuit. That means the billions of transistors are integrated on a single chip, right? What are the applications, like if you take example of your laptop or mobile phone or any digital gadget you are using, like there is a watch, there is a ATM card, and there is a some TV or refrigerator or some washing machine. Okay, whatever the digital gadget you consider, there will be some hardware chip internally. Suppose there is a laptop. In laptop, there will be a motherboard, right? It's a hardware. In your phone, there is a hardware. That's what we call system on chip design. These are nothing but the VLSI chips, where this hardware is manufactured from the digital architecture, where the digital architecture like a gates, flip-flops, registers, counters, final state machines, memories, everything is converted into the transistor level, like a CMOS transistor. Okay, so that's why we are calling it as a very large scale integrated circuit where billions of transistors are integrating on a single chip, right? Example, if you consider um, there is a classification of VLSI, like a small scale integrated circuit, a medium scale integrated circuit, very large scale, ultra large scale. Okay, I'm telling you a simple example. Suppose if I consider, let me ask a question. Let me ask a question first of all. Suppose I am telling you small scale integrated circuit, medium scale integrated circuit. Can you please mute everyone? Large scale integrated circuit and very large scale integrated circuit. What are the major differences we have observed in these four? classification. Can anyone explain?
The number of transistors are more as we increase the like from
Tracking of the transistor
MSI,
in a diagram.
as we go up, the number of transistors is increasing.
Was increasing.
Okay.
Speed of execution, ma'am.
Okay, good. Speed of execution. Any other answers? What are the applications you have seen for small scale, integrated, medium scale, large scale, and very large scale?
Like the number of transistors have
Area is
gone
more and
increased
the
from
transistors
one
integrated is
technology to
less.
another technology. Like
Hmm. Okay. Example, you already used 2G mobile phones, I think so. The keypad mobile phones, right? I'm taking the example of 2G mobile phone, 3G mobile phone, and 4G mobile phone, and 5G mobile phone I'm considering. Okay. What are the major changes we have observed in these generations? 2G in the sense it's a generation, second generation, third generation. So what are the major changes we have observed here? Example, if you consider 2G, maybe it's a keypad mobile phone where it have a very less hardware architecture. It just perform a normal arithmetic and logical operation, very simple instruction set architecture, and it run only less, very one or two applications, right? We can do the call and we can do the SMS and a simple gaming. Just it is also very simple gaming like a puzzle solving or Sudoku game or simple snake and ladder. If you are 19 and almost you are 19 kid and 2000, I think so, 2000 till 5. So I think you may aware of 2G mobile phones, how it will work, right? So if you are doing a call operation at the same time, we cannot do the message operation. First, once calling is completed, then we can able to message. Once message is completed, then you can open game and we can play the game. That's what 2G, very less features, and also there is no multitasking and less speed. Sorry. In terms of memory also, it cannot store much data like 120 bit data or 256 bit data. It doesn't store, right? Coming to the 3G mobile phone, it is some more advanced compared to 2G. In 3G mobile phone, like there is a smartphone, just like a touch is introduced in 3G mobile phone, and not much speed. It just like a okay normal good level of touch is introduced, and parallel applications can be run. We can call at a time and we can do message at a time, and we can play some simple games. And also camera pixel quality is also very less, poor quality in 3G mobile phones, right? Even network quality also very less. And coming to the 4G, there are a lot of advancements coming compared to 3G, like in terms of camera quality, or in terms of speed, in terms of bulkiness of mobile phone, in terms of processor cores. There are more good features in 4G. We can do the multitasking and also speed is more. Okay. And now whatever we are using 5G mobile phones, these are very advanced level, right? We are able to do lot of multitasking. That means we are able to run lot of applications at the same time. We are doing the call at a time, using the WhatsApp at a time, playing the games at a time, listening the music at a time. So not only these normal things, nowadays we are running a lot of AI applications also. AI applications within a second, just within a fraction of seconds. Even nowadays, from last few weeks, if you observe, a lot of AI tools we are using to create the images and everything. Lot of speed is also increasing in the mobile phone. We are able to use those much of complex applications. Okay, how it is possible actually? Only because of internal hardware we are using. Is that correct?
Yes, ma'am.
So because of
Yes, ma'am.
internal processors, we are using nowadays. There are a lot of processors in the mobile phone or even in the laptop. We are not just using a simple central processing unit. We are using graphic processor, digital signal processor, multi-signal processor, even image processor, audio processor, video processor. There are a lot of processors we are using in any mobile phone or even any laptop or even any digital gadget. That is what the performance we are easily observe from the 2G mobile phone to present mobile phones, right? Only because of internal processor capability. Okay, simply you can observe why all these things cannot be done in 2G, because processor is not capable of doing all those things, because processor is not capable of running all those instructions, the complex instructions. But nowadays our processor quality is increasing, our core capacity is increasing, we can able to run the complex instruction sets, we can able to run the graphic cores. There are lot of hundreds of graphic cores in the mobile phone. This is what the major advancements we are seeing in the present technology, right? Clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so my question is, suppose example, um, like there are different types of processor technology, right? How many of you aware of ASIC design and FPGA? How many of you aware of ASIC and FPGA?
Hello. Am I audible to you?
Yes.
Hello.
ASIC, ASIC design means it is specifically designed to a particular application specific integrated circuit.
Yeah. ASIC chips are application specific integrated circuit. Okay. So example,
Hello, ma'am. Am I audible?
yes, you are audible. Am I audible? Hello.
Yes,
Yes,
ma'am, you
ma'am.
are audible.
Okay. Okay, so ASIC chips means application specific integrated circuit. Those are all olden chips. Like there is a motherboard. How many of you aware of motherboard in a computer? Your olden days, like your childhood days, you have used computers in your school. Like there will be box type computers, very complex computers. CPU will be there, motherboard will be there, keyboard, mouse will be there. In that, if you observe in CPU, there will be a motherboard like this. Okay, motherboard is nothing but this is what the technology we have used based on the PCB board. Okay, so for clear picture I can show this example. If you see, this is what the motherboard, this green color, if you observe, this is what the PCB board. In your laboratory, in your colleges also, you have seen this PCB board, right? On top of that, we can integrate lot of components. Okay, so in this motherboard, what are there? Different types of components, like there is a processor. On top of that, there will be a fan also, cooling fan. If you observe in your olden computers, there will be a cooling fan, because if the processor get heated, it doesn't work properly, the laptop will go to hanging mode, or sometimes it got stuck, and the internal hardware will be collapsed easily, the age will be decreased easily, because of this cooling heating purpose. So always we need to cool that processor to work properly. So there will be a cooling fans. And if you see here side, there are some white color ports and also blue color ports. These all are PCIe ports, and this side there are memory slots, memory ports are there. And if you see, for every laptop or computer, we will see lot of ports inside. There will be USB port, some audio port will be there. Olden computers have CD port, DVD port. There are a lot of ports internally. And if you see here, lot of bulk circuitry, there are a lot of capacitors and some integrated circuits. Everything is combined on a single motherboard. This is what exactly VLSI. VLSI means it's a very large scale integrated circuit where billions of transistors are integrating on a single chip. That means, first of all, to design this motherboard in hardware level, we need to consider the specification of the design. Okay, example, you are using some mobile phone. Okay, whatever the version, maybe it's a Samsung or a Motorola or even iPhone. There are a lot of mobile phones. Okay, anytime whenever you are purchasing some mobile or laptop, you will check with the features, right? What is the RAM, what is the ROM, what is the camera pixel quality, what is the battery life, what is the processor generation, what type of generation we are going to buy. Everything you will be checking, right? Those all are hardware, internal hardware things, the core, processor, the memory, everything. Okay, so according to the version, according to any project, okay, we need to take the specification first of all. In industry, they will consider the specification first of all at a hardware level. Okay, so according to the specification, they will be drawing some computer architecture. Computer architecture means, suppose here there is a chip. In this chip there will be a memory. Please mute everyone. In this chip there will be a memory. In the memory there will be different types of memory, like a RAM, ROM, SDRAM, SRAM, some memory controllers, DDR controller or DMA controller. Every block have a particular hardware. Every block have particular hardware. Like that we will have lot of blocks. IO peripherals will be there, different types of processors will be there. Like that we will build some architecture in a software, just manually, pen and paper. With pen and paper we are just drawing this architecture, and we will get to know some specification with hardware features. Okay, now these all are nothing but a digital circuitry, like whatever we are learning, the adders, gates, like multiplexers, demultiplexers, registers, counters, FSM, memory, everything is combined into the architecture. Okay, by using that architecture, we are going to write the Verilog program. Why we are using Verilog program? It's a hardware description language where we can generate the hardware circuit netlist in software. Why? Because manually generating the lakhs of gates, crores of gates, it's not a very simple thing, right? So that's why we are using a hardware description language to create the software for digital circuit, digital architectures. Okay, so like that, a software copy we will get like this, a motherboard architecture. Okay, now we need to do the functional verification in VLSI, which is a most important role by using the system Verilog and UVM. From the functional verification, if everything is correct, because I am generating a design, I am generating a gate like this, I don't know whether this gate level circuit diagram is correct or not. Okay, so if I want to check that whether this gate level circuit diagram is correct or not, I need to do the functional verification. Okay, suppose for easy understanding, I am taking A is equal to 10, B is equal to 15. Okay, I am doing a adder circuit. I am generating a adder circuit to this A and B, and I am doing A plus B. And functionality I am going to verify. What is the functionality of this adder? A plus B. A plus B is equal to 10 plus 15. 25 should be get at the output side. But I am getting some answer like a 20. Some answer like 20. So here answer is wrong. Even my circuitry is looking correctly, but my answer is wrong after doing the functional verification. Okay, so that now I can tell this circuit is not working properly. Somewhere I did the mistake in RTL design. That's why I'm not getting the functionality output correctly. So again, we need to go to RTL design and we need to check. That's why functional verification is very important. Okay. So once we got the perfect RTL circuit netlist and 100% verification is done, then we need to send this circuitry to the backend process where we can dump this circuit onto the silicon wafer. Why we need to dump onto the silicon wafer?
To get hardware.
Because VLSI is nothing but it's a integrated circuit where we are using the semiconductor material to design those integrated circuits, right? One of the best semiconductor material is a silicon. Okay, compared to germanium, silicon having the good conductivity, so silicon is mostly preferred. Silicon is nothing but what is the raw material for silicon?
Sand.
Sand. After heating the sand at some certain temperature, we will get some liquid form, and that liquid form we will keep into the cylinder, and we will make it as a thicker, and we will we cut into the wafers. To that wafer we will be dumping the software RTL design, whichever we got from the Verilog design, that will be dumped onto the wafer by using the placement, routing, clock tree analysis, physical verification. After doing all these steps, one integrated circuit will be getting ready like this processor, like this motherboard. Is the screen visible?
Yes, ma'am.
Yeah.
Just a second. Like this motherboard, we will get a hardware after doing the both front end and back end. That's what exactly it means ASIC design. ASIC means application specific integrated circuit, where it is a permanent processor. It cannot be done reprogrammable, because these are programmable at the time of manufacturing side. Okay, at the manufacturing time only we are dumping the program into the silicon and making the hardware according to that specification. So it is not reprogrammable. Your mobile phone or your laptop, whatever the hardware you are using, those all are ASIC chips. Once it is programmed, we cannot reprogram it. Even it is even after some time it got damaged, if the processor is not working properly, even we cannot reprogram it. Okay, that's what ASIC chips are. This is what the process we need to do the ASIC or ASIC design. Okay, did you got it, everyone?
Madam, you missed the physical
Yes, ma'am.
design and analog layout steps.
Yeah.
You were saying that Verilog will be directly dumped in the chip. Like Verilog is only language for logic, no, madam? It's hardware description language, right? But there is a process for layout process also, right? That's physical design and analog layout process.
Hello, am I audible now?
Yes, ma'am.
Okay, yeah, actually there will be lot of steps, like there will be analog layout. Layout means what? As I told before, whenever we write the Verilog programming, that Verilog program will be converted into the gate level circuit netlist. Suppose there is a full adder. What is the full adder? Full adder have the three number of inputs, which is a sum. The output is AX or BX or C, and there will be three AND gates, BC plus CA plus CB, and these are given to the one OR gate. This gate level circuit netlist will be converted into the universal gates, every basic gate. That universal gate netlist will be converted into the CMOS transistor, because we are using the CMOS transistor technology, and there are a lot of technologies like FinFET, GAFET also. We will converting the every gate into the transistor. For every gate here, the transistors will get nearly XOR gate 8 transistors will get, AND gate also 4 transistors will get, OR gate also will get 4 transistors, or even 6 transistors will get. So like that, a simple circuit, if we get hundreds of transistors, if we take in real time, we will get billions of transistors. Okay, this transistor will be converted into the layout. What is mean by layout? You already know the stick diagram, right? You have learned in your BTech level the stick diagram, colors, the like this. This is what the exact transistor. Here metals will be represented with some color, polysilicon is represented with some red color, n-type diffusion will be represented with green, p diffusion yellow, because CMOS means we have PMOS plus NMOS, right? So here n diffusion, p diffusion, contact means black color. This is what the layout. If you see even any video, suppose if I show example, let me show you. Suppose even you can watch this video after your session carefully, how whole manufacturing process will be happen from silicon to uh, how the RTL design will be taken, the clean rooms, these are what the clean rooms, and how these wafers will be cutting according to the sizes. Okay, they will be considering in terms of micrometer the wafer size, and what is the chemical reaction, like there will be the table, right, periodic table, how the silicon material atomic structure will be looking, a boron, and how the clean rooms, the periodic table. And this is what the transistor technology, like planar CMOS, how the PMOS and CMOS will be, NMOS will be connected, and how the current flow happening here. And if you see here, this is what exactly you have asked, the layout. If you observe here, left side, this is what the gate level circuit netlist I have drawn before. This gate level circuit netlist will be converted into the transistor layout like this, right side, this transistor layout. In gate level circuit netlist, we do the functional verification. Functional verification is different, testing is different. Testing we do in various levels, like front end pre-silicon testing will be there, post-silicon testing will be there. Even in hardware, we call a team like validation is also related to testing. Even in VLSI, we have the DFT, design for testability, by inserting the scan chains by using different mechanics, like mechanisms like ATPG mechanisms. We check the design, the stucket faults. We check any fault errors or fault mistakes, like hold time analysis, setup time analysis. Everything will be tested. Testing is different. Functionality verification is different. Okay, functionality verification means, before I told, if I got a plus b equal to something in place of actual value, that's what functionality. Like if I tell more clearly, suppose there is a full adder. Full adder have its own functionality, like addition of three inputs, we got the sum and carry as an output. Multiplexer have its own functionality, like based on the selection lines, any one of the input will be selected and sent to the output. Encoding have some functionality, like physical data will be converted into the binary data. Decoder have some functionality, register, counter. So every circuit have some functionality. That functionality checking, that logic checking is nothing but functional verification, whereas every node to node testing is nothing but DFT or validation. Okay, so here in front end, we need to do the functional verification and need to test every node to node here. If you see here, every node to node testing is important. Once that is clear, once we got the proper output after testing, then this circuit will be converted into the layout stick diagram. This is what the colors stick diagram. This is only one gate, one, not even gate, one transistor stick diagram. But in real time, we will have the billions of transistors. So how the billions of transistors will look like? If you see right side computer, you will observe the lot of lines, color lines. Those color lines are nothing but whatever the left hand side diagram is there, that diagram will be converted to right side. See how the right hand side circuit is converted here. If you observe, this is what exactly the netlist. We have both analog circuits and digital circuits. Whatever it is the process to convert into the layout. Mostly this is what the backend process. Here, after it is converted into the layout, to dump onto the silicon, we do the placement, routing, clock tree analysis, even floor plan. First we need to do the floor plan. Okay, this is what the right side layout. Even you can observe this video, see how it is looking, and this is how it looks, the billions of transistors. Every node to node, here we need to observe the circuit properly and make the connections. And this is what the clean rooms, the manufacturing process in VLSI. In India, we don't have any manufacturing hubs, right? In different countries like Taiwan Semiconductors or even US, there are a lot of manufacturing hubs. And maybe soon India also will get, right? So this is what exactly the process happening here. You can take your time and just watch afterwards. Did you got the clarity now what is meant by layout?
Yes, ma'am.
Okay, okay, fine. So what's my, where we are? Yeah, so this is what the process. Yeah, tell.
No, ma'am, nothing.
Okay, so this is what the ASIC chips are. ASIC versus FPGA. FPGA means it's a field programmable gate array. I think most of you people already done some VLSI projects or even IoT projects using Arduino boards or even microcontroller boards you have used, I think so. So if you see here, these FPGA boards are nothing but it's a chip. It's like a kit. The board we can buy and we can do a lot of projects using FPGA. Even I can show you some board here, FPGA, where we can dump the where, like this board, where we can dump the code, Verilog or VHDL code, and this FPGA will work as a different application like a traffic light controller, digital watch, or digital alarm, or any for gaming purpose. This is like a hardware where we can reprogram. Before I have shown you ASIC chips. That means once the program is dumped onto the silicon, it never reprogram. Those are ASIC chips, nothing but motherboards. Motherboards are the ASIC chips. These are the FPGA. Did you got the clarity, everyone?
Ma'am, so FPGA is like temporary testing board, right?
Yeah, it's like a temporary. Mostly we don't use for permanent applications, for testing purpose. If you want to test any, like even now any mobile phone is going to manufacture, means first of all that hardware will be dumped into the FPGA, and then they will check whether the hardware circuit is working fine or not. Then only they will dump into the silicon permanent chips. So FPGAs are like temporary, which is reprogrammable.
Okay, ma'am, thank you.
Okay, everyone got the clarity?
I'm sorry to interrupt, but I can't see this.
Yes, ma'am.
My screen is visible, everyone. I have opened system on chip design
Yes, ma'am.
Yes, ma'am.
PPT.
Yes, ma'am, it is visible.
Okay, okay. So I think I have given you the clarity what is meant by VLSI and what are the different generations we have seen till now, and what are the ASIC chips, FPGA, and its applications, right? Now we will be going to discuss about the system on chip design. Okay. Shall we start?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay.
Yes, ma'am.
See, what is mean by system on chip design means, example, before I have shown you motherboard for PCB, which is all the components are dumping onto the PCB board. So this is what we have seen in our olden days computers. But if you observe nowadays the laptops or even mobile phones, are we seeing any PCB board in our laptops or mobile phones? No, right? Even it's a very complex, very thin boards we are able to see. We are not using any complex hardware, and also which are very less weight, very compatible. Just 100 grams mobile phone, even 200 grams mobile phones only we are using, even in laptops also. But olden days laptops are very heavy weight, like even 1 kg weight laptops also there, lot of laptops. Okay, that's what the complex hardware we have used in the olden days, and nowadays what the compatible size we are using. Okay, so coming system on chip design is the present trend. From last 5 years, 10 years, we have replaced the ASIC designs with the system on chip design. System on chip design is also a permanent chip, same as a ASIC, but SOC means it's a single chip. Okay, on a single chip we are integrating multiple functional blocks. Okay, example, if you see here, there is a processor here. Processor is a single chip, it's a single integrated circuit. Like that, system on chip is a single integrated circuit. On that circuit we are putting all the functional blocks. That's what exactly system on chip means. System on chip hardware.
Hi, ma'am. I have one doubt.
Yeah.
I think in ASIC also it has multiple macros, right? They're also having memory
Yeah,
like
there
that.
will be, yes. Even it's a motherboard also. Motherboard have the memory, it have the ports, it have the PCIe slots. PCIe slots means, if you see, there will be like a bus type wiring. Bigger size
Okay.
wiring will be there, like lanes, PCIe lanes. I can show you here. PCIe lanes. See here, these are the PCIe lanes, and if you see how the wire, PCIe wire lanes means just ports, wires means like this. If you see how bigger size wires we will kept in the motherboard, but nowadays complexity is very reduced, not like this. Okay, but system on chip means, if you see here, only single chip. This is one integrated circuit. On one integrated circuit there are lot of functional blocks. See how small size it is, just a chip. On top of that there are a lot of ICs. But if you see a motherboard, here it's a very complex bulk size PCB board. On top of that we have integrated multiple components. Are you able to observe the difference?
Yes, ma'am.
Okay, so this is what exactly system on chip designs we are using nowadays in the mobile phone or even in the laptops. Okay, so on this concept I am going to discuss more in depth to give you more clarity for today and tomorrow. Till now whatever I have discussed is just an introduction about the VLSI. Okay, so coming to the system on chip design, this is what exact architecture we can find in any mobile phone or even laptop. This is very just a simple architecture, but in real time, every company have its own designs. Like there is a AMD. AMD have its own architecture, SOC architecture, like for Ryzen processors, and Intel have its own architecture. Qualcomm have its own architecture. Even Samsung have its own architecture. Okay, so but in any architecture, these are the basic building blocks. Okay, Example, if you see, there is an iPhone and there is a normal phone. Okay. iPhone comparatively a normal phone, iPhone have a lot of features and it is also very costly, right? Like in terms of camera quality, in terms of in terms of battery, in terms of size. Even most of the iPhones are just very less size, just 100 grams. Like that, there are a lot of phones like Google Pixel or lot of phones. Okay, but every company have its own system on chip architecture. Okay, it have different types of processors, different types of graphic processors, different types of memory modules. Okay, so system on chip design is nothing but it consists of several functional blocks like CPU. If you see here, there are there are different blocks. First block is a, just a second. If you see here, it's a CPU subsystem and there is a design specific subsystem and application specific subsystem, memory related subsystem, and some interconnects related subsystem, and wireless subsystem like where it have Wi-Fi, Bluetooth, GSM modules, and there are some security related subsystem and IO peripherals related subsystem. Subsystem means different different functional blocks will be kept into the one specific block. Okay, example, a system on chip design have cluster of subsystems. A subsystem have cluster of IPs. What is mean by IP? Suppose if you see here, there is a CPU subsystem. It's a subsystem in an entire SOC. This is what entire SOC, entire system on chip design. Okay, in that one of the subsystem is CPU. In CPU, there is a A57 one block, another A57 another block, another. Like there are 4 A57 blocks. These are the individual IPs we can call, and also these are the core in the processor. And here A53, A53, 4 cores are there. Like that L2 cache memory is there. Can you tell me what is mean by a processor and what is mean by a core?
I think core is the internal component of a processor which performs a specific task.
Actually, it's a multiple unit of processing. One unit is one core. We have several processing units. So, for let's say 4 cores, so it has several 4 individual processing units.
Okay, that's good. Any other answers remaining? Are you there?
Core is the processing unit within the processor, ma'am.
Okay, what is meant by a processor first of all? What is meant by a processor?
It is the main chip, ma'am, in the computer or any hardware.
Yeah, it can do any kind of calculation, maybe arithmetic or logical operation. It can get things done. So basically, this orchestrates the mathematical and logical operations.
Okay, what is of doing? Yeah, tell.
CPU performs tasks with the help of both softwares and hardware.
Okay, okay, good. Okay.
Processor is
okay, tell.
It is a combination of ALU and control unit, ma'am.
Mm-hmm.
Actually,
Can you
basically, a processor is nothing but a brain of any electronic device,
okay.
and it is responsible for executing the instructions and as well as handling all the calculations which are required in that electronic device.
Mm-hmm. Okay. Okay.
Processor can
How
do the
many types of
multiple.
processors? How many types of processors are there in real time?
Two types of processors now,
CPU and GPU.
Okay.
CPU and GPU.
CPU,
Okay.
GPU.
Okay. Okay, that's good. Okay, let me explain. So processor is nothing but whether it's a general purpose processor like central processing unit or graphic processor or digital signal processor or multi-signal processor. There are a lot of processors. Okay. As some of you told, processor is the brain of the computer. We already know that thing. We from childhood onwards we will tell that point. Processor is the brain of the computer, right? However, the human brain is working. Example, take a human brain. Okay. Whatever we are doing some task, like I am talking something, I'm writing something, I'm going somewhere, I'm walking. So all these instructions will be getting from my brain, right? Not only these instructions, while I am talking something, I may think a lot of things will be running in my brain. That means lot of things it is thinking. My brain is thinking lot of things, and I am doing something, and I'm whatever I'm doing something, that signal also sending to the brain, right? So it is getting in and out. That means receiving and transmitting. Okay. So if my brain doesn't work properly, then what I do, I don't know what I'm doing. My system is not good that time. Maybe we can call it as a mad, right? Even your computer, if the brain is not working properly, that means if processor is not working properly, the computer will go to dead state, right? It doesn't know what it doing. It go to some hanging issues. The system may go shut down or some stuck. It gets stuck somewhere. So a lot of things will happen, right? So it is like our human brain. However, the brain is giving lot of instructions to the human body from top to bottom. And however, our entire human system is working based on the brain. In the same way, this entire computer system will work on processor, will work only on a processor. The instruction to every port to your computer, whatever the internal chip is there, like it's a memory chip or even Wi-Fi or GSM, whatever the chip is there internally. So if the system is working properly, means all the instructions are giving from the processor. All the instructions are giving from the processor. Okay, understood everyone?
Yes, ma'am.
So
Yes.
here, example, how the processor will give the instructions to the different system. This is what entire system, which is a non-core, which is a non-core. Okay, that instruction is nothing but we are writing the assembly language programming, right? I think you may heard about the assembly language programming instruction set architecture in your college days, in your third year BTech or final year BTech. There is a assembly language programming where there will be instruction set addressing modes, pipeline architecture, non-pipeline architecture. We write a lot of instructions like arithmetic instructions, logical instructions, branch type, jump type, loops. There are a lot of instructions. That is what exactly we are writing a processor. Suppose there is a different types of processor, like Intel have x86 processor, AMD have Ryzen processors, ARM have some RISC processors, Samsung have some Xeon processors, Qualcomm have Snapdragon processors, which are best for mobile phone and also for laptops. Okay, that means Hello. So that means there are different types of processors where we are using in our computers and also which are sitting in a system on chip design. That is the processor, that's the brain of the entire chip. It is working where it is passing multiple instructions to the entire chip. In the same way, there are graphic processor. What is meant by graphic processor? Before moving to the graphic processor, let me discuss about the core. Suppose here I am telling a processor. It have different number of cores, A57 core, A56 core, 4 number of cores and 4 number of cores are there. Core is nothing but it do a specific task. It performs a specific task. That means one core can run 2 tasks. Like the 2 cores, 4 tasks, 3 cores, 6 tasks, 4 cores, 8 tasks. That means if there are more number of cores, the functionality will improve more. The processing speed will increase more. Okay, within 1 minute, if there are 4 number of cores, 8 number of tasks can be done. If there are only 2 number of cores, only 4 tasks can be done within a minute. Okay, that is what exactly core means. Every time whenever you buy the laptop, you will check the number of cores, right? Whether it's a quad core or octa core or 16 number of cores, you will check the laptop and you will buy. Is that correct? Core is nothing but processing speed. Core is nothing but processing speed. Okay, sometimes there is a laptop, your laptop. You are running more number of tasks at a time. You are installed the complex gaming, mostly video gaming or any complex games you have installed in your laptop. Okay, so that time sometimes your laptop will get a slow down. Why? Because due to the processing speed, due to the core capacity. And also example, you are using some laptop. Okay, and suppose it's a MacBook. Okay, it's an Apple laptop. Apple have some OS, right? Mac OS. There is a Mac OS in your laptop which is having 8 number of cores, So you are running some software anyway in your Mac laptop with 8 number of cores. Okay, now the processing speed is very high. Within just a seconds you are doing lot of task and it's very high speed. It's running at high speed. Okay, but whenever you have installed another OS again, that means half Mac OS, half Windows OS using virtual machine or like that, or half Windows OS, half Linux OS. So your entire laptop you have divided into the 2 OS because of your you have some any specification. Okay, like based on your requirement you have installed the 2 operating systems. Okay, now the same 8 cores will be divided into 4 cores, and for Windows it will be divided into 4 cores, right? Before, whatever the gaming or whatever the software applications you are running on Mac OS at 8 cores, now you are running same applications with the 4 cores. Now what happens?
It depends on the application, ma'am. Like if a small application it doesn't matter, but big application this may matter, because for a small code, let's say have 8 core, right? But we are
Yeah,
not getting
we
application
can
is
consider.
small. So even if we have 8 core, 6 core will be on idle mode. Only 1 or 2 core will be running, depending on the application.
The speed
Yeah.
has reduced, ma'am.
Yes, depending on application. Suppose if we consider the complex one only, because the same softwares whatever I have run with the 8 cores, again the same softwares we are running with the 4 cores. Maybe it's a complex one only if we think. Okay, so coming to the 4 cores, automatically the speed will be reduced. The processing speed will
Because
be reduced,
I mean,
right?
if we have, yes, ma'am. If we have multiple cores, that means we have parallelism means parallelly we will do the task. I mean, we will divide the task and it will be done. So the task, let's say if we complex, if we have 8 cores, so that task will be divided into 6 different parts, and each part will be done. So the execution it will be faster. But if application is small, so other, let's say we have 8 core, but application is small enough, so maybe 2 core will be working, other 6 core will be idle for power saving purpose.
I understood. You're telling the small application and complex application. Okay, that's fine. That's fine. I am telling, if it is a suppose complex application, if we consider, if these complex applications are running with the 8 cores perfectly without any delays or without any less speed, okay. But coming to the 4 cores, automatically the speed will be reduced, and also sometimes we will get the hanging issues also, slowdown issues also with your laptop. Okay, so these all things will be dependent on the processor and internal number of cores. Okay.
Yes, ma'am.
And
Apart from
also,
ma'am, this depends on the application, like GPUs, TPUs, NPUs, and CPUs. So depending on the what kind of application, for which kind of application it is being used, CPU sometimes may perform better than GPU, depending on the application. Even NPU can perform better than GPUs, and sometimes CPU can perform better than TPUs. Depends on the application, ma'am. So based on that
yeah.
application, it can be.
Yes. That is also depends on the application. I will explain that thing clearly. Yeah. Another thing I want to tell. Sometimes, like example, suppose you are using a normal mobile phone. Suppose a 10,000 rupees mobile phone is there. Okay. At the same time, you are using iPhone. You know iPhone is a more powerful. Why it is more powerful compared to 10,000 mobile phone? If you if you observe, suppose you are playing some high speed game in the 10,000 rupees mobile phone, whatever it is, okay, and you are playing same game in iPhone like PUBG example, or any fast gaming, any game. Okay, if you see major difference, first one is a slowdown in the sense very slow. The game will run very slow in a normal mobile phone. Even touch also doesn't work properly. But in iPhone, it will within just fraction of seconds, it will just keep on running very smooth, and also the speed is also very good. Okay, we don't get any hanging issues, slowdown issues in the iPhone. And also quality of video, you can easily observe the quality of video in a normal 10,000 mobile phone and even iPhone. What is the major difference we are observing here? Because
Have large
processor.
number of processing units. We have
Huh.
multiple cores, and all the cores are doing things parallelly. So parallelism is promoted, and because of this application, I mean, multiple cores will help in doing things faster.
Yes. See, one thing, why the iPhone is very costly and the 10,000 mobile phone, just it's a 10,000 means, first of all, number of processor, number of cores. Okay, because of very less number of cores in that mobile phone, 10,000 rupees mobile phone, the processing speed also will be less. And also it doesn't support for high speed applications. Whereas in iPhone, there are more number of general purpose cores, and also there will be lot of graphic cores. Nowadays, in most of the iPhones or even laptops, there are having lot of graphic cores. Why? Because nowadays everything is a AI application, AI related application. AI related application means what? It totally depends upon the video quality, image quality. That image quality, video quality totally depend upon the graphic processor, not general purpose processor. General purpose processor will just do the logical operations, just it do the instructions, entire functionality it will be checking, not related to the high quality pixels. High quality pixels will be dependent on the graphic processor. The signal issues, internal hardware signals, that means the data transmission between processor to memory, memory to port to IO peripheral, the fast signal transferring will be dependent on the digital signal processors, like that multi-signal processor. The quality of image dependent on the image processor, the quality of video dependent on the video processor. So because of these many processors are inbuilt in the good mobile phones, whatever you are buying with a high amount, those are having a good hardware inside in terms of camera pixel quality, or if you observe the memory, 256 byte or 560 GB, whatever it is, because of internal hardware. Okay, did you got the point, everyone?
And basically, when this task, memory is very important. And these they are critical for the faster.
Your voice is breaking actually.
Wow. Yeah, ma'am, am I audible?
Yes, yes.
Yeah, ma'am, actually, I was saying, apart from the processing codes, we need memory response, that is L1 and L2 cache. So this is also very critical, even more critical than the processor speed or core, because if we won't get the response timely from the memory, it won't be able to process it, keep on waiting.
Okay, yeah. Okay, you are asking about the cache memory, right?
Yes, I mean, for the processing, I mean, we can say the speed of processor depends on the core, number of core, as well as L1 and L2 cache
Yes,
status.
yes.
Because even if we're having very good,
Actually,
very good
in
processing
every
but it doesn't have further.
yeah, let me explain. Even if you see here, there is a L2 cache. Most of the system on chip designs or even ASIC chip designs, there will be L1, L2, L3 cache memories in the processor itself. Okay, so these are nothing but level 1, level 2, level 3 cache memories we can call. That means these are the inside the core and also very fast. Like L1 cache will be in terms of KBs. Okay, L2 cache will be in terms of MBs. L3 cache will be also in terms of MBs and also GBs. Most of the SOCs today we are using L3 cache only. That means it have across all CPU cores for fastest memory allocation, for multi-core communication purpose, to reduce the traffic. Traffic means the internal transactions between different functional blocks. To reduce the traffic, we use these cache memories actually. The data can be transferred immediately, which is a super fast with respect to the CPU. Okay. So, is there any other doubts from others, remaining people? Am I audible?
Yes, ma'am.
Did you all understood what is mean by a processor, what is mean by a core?
Yes, ma'am.
Okay. So, if you observe here, in this system on chip design, there is a processor and there is a graphic processor, which I told already. The graphic processor are very crucial nowadays compared to normal processor. Graphic processors are more in every mobile phone or laptop nowadays, because we are getting everything is AI applications. AI applications will generate very high quality pictures. Okay, it is generating very high quality and also very fast. Okay, without any delay, right? Only because of internal hardware system. This totally depends on internal hardware system. Okay, if we don't have that strong hardware internally, on top of that, whatever the applications are running, whatever the softwares are creating, there is no use. It cannot run. The software doesn't support if there is no strong hardware inside. Okay, so that is what exactly the power of VLSI, the power of circuit design, the power of chip design. So in future you may get the doubt, will the VLSI engineers jobs will be reduced Can AI replace the VLSI jobs? It never. Okay, it never. Why? Because whatever the softwares we are getting now, everything is AI dependent. So to support the AI softwares, definitely we must have a strong hardware. Now we came to the nanometer technology till 3 nanometer, even 2 nanometer in current iPhone 17. Okay, so once the nanometer size is reduced to 1 and 0, there is no way to store the data in transistors. Then we have lot of technologies are coming in the market, like we are having neuromorphic chips, quantum computing, photonic chips, 3D IC chips. So hardware side we are developing more to support the hardware. So that's why the VLSI engineers never the AI never replace the VLSI engineers. Okay, these are all not open source. Only industries, only in the particular industry, the engineers, scientists need to make these hardware chips. These are not open source, and even AI cannot. AI cannot create new things. It just make the task faster. It just do the task smarter, right? It doesn't create any new chips. It doesn't have that power, right? So you never doubt that AI will replace the VLSI engineers. Okay. Another thing we need to discuss different types of processors. Okay, as I told, system on chip design is nothing but it's a combination of subsystems. It's a cluster of subsystems. Every subsystems have n number of IPs. IP means each IP have one task, specific task. Okay, suppose here there is a memory. Here there is a memory subsystem. In the memory, there are different types of IPs, like RAM is a IP, ROM is a IP, DDR memory is a IP, DMA memory or DMA controller is a IP, PHY is a IP. There are different types of IP. These cluster of IPs combinedly called as subsystem. Okay, if you are a fresher, whether you are studying BTech or MTech or even masters, if you are looking for a job in VLSI, okay, if you are planning for a job or if you are planning for an interview in VLSI, you must learn the industry projects properly. Okay, this is what exactly we are going to discuss today and tomorrow. Tomorrow we will totally discuss into these protocols and the processor architectures, memory controllers and all. Okay, so what exactly you need to learn means whether you are a design verification engineer or physical
What is a
design
cache?
Sorry,
What is a cache?
what is a cache?
Yeah.
Actually here different types of cache memories are there, like it just the interaction, it's a bridge between the CPU cores, between memory and CPU cores, just to improve the multi-core communication, and it just reduce the RAM traffic in the sense multiple instructions will run parallelly, right, in a bus. To reduce the traffic, it already stores the data. There will be instruction cache and data cache. It already have some program instructions. It store the program instructions and it already stores some data. So for fast high speed processing purpose, to reduce the traffic, there will be a cache memories.
We can have hard disk also, right, to store the storage.
Yeah, hard disk also will be there.
No,
Even
actually,
in hard disk, there will be a memories, same cache memories.
yes, actually, response time, everything is all about the timing risk, right? If we are talking about, let's say we have clock frequency of 3 gigahertz, right?
Okay.
If we have a clock frequency of 3 gigahertz, right? So the time period of this could be something in nanometer range, right? the time that means the time short time period will be very less. But if you talk time the response time of the hard disk, it is in millisecond range. So even
Yeah,
if
of
how
course,
much
sir.
faster
Yeah, hard
but
disk
it may
also.
not meet the
Yeah, it compared to
maximum
RAM and
maximum range it
cache.
is
Tell.
yes, that is in I mean, it is in microsecond time, right? So even if we have designed a faster processor, but it will have to wait for the memory to get data from there and then store data, right? So, so the bottleneck is memory response, and that is and in order to solve this problem, we have cache the fastest so that we can get the fastest response in terms of L1 and L2.
Okay, but
Right, ma'am?
comparatively, RAM and cache, hard disk is somewhat slow. Whether it's a permanent storage device, whereas cache and RAM will lost the data. But even hard disk is a permanent, but it works at a very low speed, slower
Yes.
than cache.
So cache will lose the data when we use cache. Huh?
Yeah, of course, RAM also will lose the data.
Okay.
Yes. It's but yes, as long as power is there, so it will remain. It will take itself and will
Hello.
but permanently
No, I think your
we
voice
need
is
hard disk.
breaking.
Yes.
It seems your voice is
Actually,
breaking.
cache is very fast compared to hard disk. That's why mostly cache will be preferred. Okay. And also just in cache, we can store only in terms of KBs and even just a megabytes only. But in hard disk, we can store till TBs.
Okay. So why can't we have what TBs in cache so we can have faster data speed?
Because it is very slow, very small, right? For cache. Because it
Yeah, we
works
can
at
have.
very high speed. If it need to work at very high speed nanoseconds means of course it should have less data storage. That's why
No,
it
can't
works
we have
with
a
super
cache
fast.
of 1 TB so that
And
we
to
can
add
ignore
on,
the
it is
There
more
are
costly.
levels based on the levels like L1, L2, L3. We can achieve that.
It is more costly also to build the cache.
So
That's
since
why.
it's more costly, we are not moving to cache for high huge storage. Huh?
Yeah, of course.
That is not only the reason, I guess, because if you want more size of cache, it will take more area. So the size of the chip will be increasing parallelly if you want more size. And the cache is
But
not a
hard disk,
permanent storing device. Cache is
no
not
hard disk,
permanent storage
hard
device.
disk.
RAM also not. Hard disk is the
Even if
external
you take
device
hard
generally.
disk
It
or
is not on
cache,
the
it
chip.
both takes same data. Like if I store some data, both takes the same amount of size, right? So if I take some
Yeah,
data,
but it is yeah. But
if I take
that
some data
data
which is
is
of
in the form of KB and MB. It is not storing all the data of your hard disk. It will store those data which is repeatedly used.
that's what I'm asking.
Yeah.
So we can
So
store it
cache
in
is not a
hard disk
permanent
also, right?
memory.
That is permanent. So hard disk itself is
Yeah. If you
permanent.
want to store
So
your
we can
data in
fetch.
the hard disk, then you can use hard disk. Hard is an external device.
No, I mean, since it is permanent, we can fetch it from there only. So if we want repeated
But it will
data,
take long time to fetch the data. But it will take long time to fetch the data because the design used in the design of hard disk is containing the capacitor based design or not RAM CMOS based design. So that's why if you
uh,
want to store your data permanently,
okay,
then you can go for the
uh,
hard disk, but at the cost of
okay, there
speed.
is
an area.
Okay. Uh-huh.
Yeah.
So the technology itself is like that.
Okay. Remaining students, did you understood everyone?
Yes, ma'am.
Oh, okay. So first of all, where I am answering, first of all, I'm explaining like if you're looking for the VLSI jobs, okay, as a student level, what are the major projects and protocols you need to concentrate? Okay, suppose if you see, my suggestion is everyone must have in your resume, like there must be protocols because without protocols, your resume never select. Okay, especially for design verification engineer, even for PD engineer also. Okay, if your resume doesn't have the proper protocols like high speed protocols or low speed protocol, parallel protocols, bus protocols like AMBA protocols, if you don't have the protocols, first of all try to learn the protocols. And second thing is I can suggest any one processor related project, like whether you can do a RISC processor or even MIPS
So what is
processor.
the protocol?
Protocols, you can learn UART, I2C, APB, AHB, AXI. And
Oh, that
projects
is a
like
language or what is that? I mean, you like
You
UVM
have to
only.
follow set of rules.
language in the
Sorry.
sense, first of all, we need to design it in a Verilog HDL hardware or TL design. After generating the RTL circuit, we need to do the functional verification using system Verilog or UVM. After doing functional verification, same that RTL design you can do till GDS also in physical design, like first taking the floor plan, placement, partitioning, routing, clock tree analysis, all those things you can do even in a backend. Whatever we are doing in front end, you can do that backend also, but tool should support those files. That's it. Okay, so I'm going to explain what are the different types of architectures are there in processor. As I told, most of the companies have their own architectures, like Intel x86, ARM, RISC or CISC is there, AMG Ryzen process or
Huh?
there. Uh,
You
yeah,
were saying about the projects we have to involve in our resume. So processes, you didn't give all the examples, no?
like processor based, you can work on MIPS processor or RISC processor. And memory related, any memory related like RAM or ROM, DDR is more popular nowadays, DDR project. And also some IP level projects like a router, memory controllers, any image processing related, like that. Okay, SOC related project will be must and should, processor related, memory controller related, DDR or DMA controller, whatever. Okay, so coming to the processor, there are different types of processor architectures. Okay, first, very older version, I think you already learned in your books, microprocessor language, which is the first starting version. Von Neumann architecture and Harvard architecture. So what is the difference between Von Neumann and Harvard?
Different memories for each and every
The
article.
different buses.
And there are common buses.
One
Okay,
is pipelined and the
Different
other is
buses.
not.
okay, okay. So I will explain. Next, and nowadays, most of the computers and laptops we are using CISC and RISC processors and superscalar architectures and very long instruction set word, single instruction, multiple instruction, multiple data, out of order execution in current GPUs especially. Multi-core and many-core architectures, digital signal processor and graphic processing unit. These are different processor architectures we are using in a lot of applications. Okay, First of all, if I explain about the von Neumann and Harvard architecture, in late 1960s, 1900, that time we have used these architectures. Okay, that time we have very simple architecture. Just it performs arithmetic and logical operations with just 3-bit or 2-bit. Okay, so coming to von Neumann architecture, it have a single memory. If you see the architecture here, the block diagram, what the CPU consists of, like ALU, registers, and control unit within the CPU, and there is only single memory unit. Hello. Please mute everyone. Okay, see here. Von Neumann architecture means there is a CPU and there is a memory unit. Okay, so this is how the instructions will be fetched. Okay, so here there is a single memory. Single memory is used for instructions and data. Okay, instructions and data uses the same bus, so it is simple. There is no complexity, much complexity, and also cost effective. Okay, this type of architectures are used in early microprocessors, like first microprocessor, I think 4004 and 8008, right? That time the von Neumann architecture and Harvard architectures are used. Harvard architectures are nothing but it have separate address lines and data lines to memory. Program memory will be there and data memory will be there. Separate memories for both instructions and data, so that parallel processing will be happen. So the performance wise also it will be good compared to von Neumann. Mostly for digital signal processors and microcontrollers, this type of Harvard architecture is used. Okay, so here the instruction set architecture, assembly language programming. Assembly language program is different, hardware side is different. Whatever the program we write in assembly language program using the instruction set architecture, that instructions will be fetched into the memory. And also there is a pipeline and non-pipeline. Okay, especially we use a program counter to fetch the instructions to the memory, and it do the decode operation, execution, write back stage, and memory write stage. Like that, there are different types of stages in the pipeline where exactly we can relate the hardware and also assembly language programming. Most of the people will be getting confusion here. Did you understood?
So what is assembly language?
What is
Assembly
pipelining,
language.
ma'am?
Wait, let me explain. Assembly language programming means, suppose what you told before, processor means it's a brain of a computer. Processor means it's a brain of the computer. As a human being, how the instructions are getting from the brain for us? Some normal through the nervous system, we will get the some instruction. That is what it by default it manufactured like that. Okay. In the same way, in the system on chip design, there is a processor. Processor is generating the instructions to entire system means by using the assembly language programming. You already know the microprocessor language where we can write the arithmetic instructions, logical instructions, branch type instructions, jump type instructions like add R1 comma R2 sub R1 comma R2, like that, immediate addressing mode, direct addressing mode, indirect addressing mode. There are a lot of instructions. So by using these instructions, we can design some logical and arithmetic operations. So those instructions will be fetched one by one, and at a hardware level, we do the decoding process of that instruction, and we will write into the register. That's what long process will be happen here. Okay, What is mean by encode and decoder? Can anyone tell? What is mean by encoding and decoding?
Encoding means converting anything into binary format.
Okay.
Converting any
human
number
language
system.
to machine language. Decoding means machine language to human language.
Okay. Any answers? What are the applications of encoder and decoder? Whatever we learned in digital electronics.
Encryption and decryption.
What is mean by encryption and decryption? What is the difference between encode, decode, encrypted and decrypt?
Encrypted means some security purpose.
Okay. Okay, see everyone. Encoder and decoder means in every communication system, the common usage is multiplexer, demultiplexer, encoder and decoder. Okay, every communication system inside the hardware and also in software, whatever. Okay, simple example, if I tell at software level, after that I will tell you hardware level. Okay, suppose I am using my mobile phone. I'm using my mobile phone. This is what the transmitter. I am here at some place. This is my mobile phone and this is what the transmitter. Okay. And there is a receiver. Example, you only. You are the receivers. You have the mobile phone. Okay. Now, in my mobile phone, I have a hardware. Right. Inside a hardware, there is a processor. There is a memory. There are different internal hardware system. Okay. And even in your mobile phone also, there will be a processor. Okay. And in this mobile phone, on top of that, we have lot of applications. I have a WhatsApp, Instagram, message option, and there are different mails. There are lot of applications. And even in your mobile phone also, there are lot of applications. WhatsApp, Instagram, calling, messages, a lot. Okay. Now, how the interfacing is happen between hardware to software here? There is a operating system. Suppose if I am using Apple mobile phone, there is a iOS. OS is nothing but operating system is nothing but it's a mediator between hardware and the software. Okay. Through that only both hardware and software will be connected. Suppose if you are using some Android or even iOS, Android means there no, Android OS will be there if it is a normal phone. If it is an iPhone, there will be iOS. It's a mediator between hardware and software. Okay, that means whatever on top level I am opening, whether if I open the WhatsApp or if I open the some Instagram or even calling or messaging, all these instructions will come from hardware, from iOS to your software application, right? Suppose this is my WhatsApp, this is my application, WhatsApp application. I am sending a hi message to you. I am sending a hi message to you. Now, this hi message, whatever I sent in my WhatsApp, whatever I click in my WhatsApp, it got transmitted to my processor first. How it is getting transmitted? This H will be converted into binary value. I will be converted to binary value. Every character have its own binary value according to ASCII table. Not only for character, even for image, video, audio, any GIF, whatever. Okay, every physical data, these all are physical data. Every physical data have some binary data. Okay, so because the processor will understand only binary data, here this hi is converted to some binary language to the processor. This process is nothing but encoding. We call it as a encoding. Okay. Now the same processor, the same high message you are receiving at your WhatsApp also. Okay. How it is possible? That all things will be done in the top level, because there is a contact number to contact number, it will be communicator. That contact number is nothing but SIM. That SIM also have some hardware. That hardware chip is connected to your processor. Like that, the top level, it doesn't view for us, but internal hardware will do the same thing. Okay. So whatever this binary data we got from the transmitter side mobile phone, same binary data will get to the receiver side mobile phone. Same binary data. Okay. If that same binary data visible at output, we don't understand. Humans doesn't understand the binary data. So here same binary data will be converted to same high message or video message or audio message, whatever the transmitter sent. That process is nothing but decoding process. That process is nothing but decoding. Example, our teams only. Now we have a meeting. Whatever I talk now here, it will get 2 seconds late for you, not immediately. Okay, 2 seconds late for you. If you want to observe, you can sit one room, one person, another room who are talking, you can sit in one room and listen carefully. After 2 seconds, you will receive that message, that voice. Okay. Why 2 seconds gap means? Here it need to go to your internal hardware design, to your laptop. That hardware need to convert it binary, and it need to transmit via wireless channel, because we are using everything is the internet, right, which is a wireless channel. So that wireless channel, it will be getting the information to your receiver. The processor will get that information and again send to that software, and output will be getting. So internally there are lot of system hardware is involving, and top level operating systems are involving, and through the third party software applications we are getting the data output. Everyone understood? Hello.
Yes, ma'am.
Yes, ma'am.
This is what the encoding and
Yes, ma'am.
decoding. Physical data to binary data to physical data. Okay. And some of you told encryption and decryption. Encryption and decryption is nothing but simple example. If you observe, you are using WhatsApp, right? If you see top, when you are sending some new message to some person, you will find that 256 bit end-to-end encrypted. That means what? Whatever the data you are sending, for the data, there will be a lock. Okay. There will be a key, digital key. That key is nothing but encrypted. Your data is encrypted with that particular binary number. Again, that key will be unlocked at your receiver mobile phone only, because the data is encrypted to your end-to-end user only, which is never hacked. Okay, that's what encryption and decryption. Okay, understood?
Yes, ma'am.
Okay, this is what top level, what is mean by encoding and decoding. Okay, but if we tell in a hardware level, some of you asked what is mean by pipeline and non-pipeline. I will explain you that in just 5 minutes. Suppose, see here, as a VLSI engineer, we need to design at a top level hardware. Okay, for processor. Okay. What are the stages will be there in pipeline, if even it's a non-pipeline, to execute one instruction? Okay, what are the stages will be there? There will be a fetch, decoder, executor, memory writer, write back stage. After completing these 5 stages only, we can complete a one instruction execution cycle. Okay, so here first of all, fetching Fetching means what? These all are top level hardware. Fetch have some hardware, decode have some hardware, execution have some hardware, which is ALU. It do the arithmetic and logical operations. Write back, memory write stager, write back stager. This is totally hardware, which is in terms of digital logic design. Okay. So here, first of all, there is a fetch stage. Fetch means what? The instructions should get from the memory. Okay. That's what we use the program counter here. In microprocessor language, we have special purpose registers and general purpose registers. If you see in your microprocessor language, there will be special purpose registers like accumulator, program counter, instruction register, data registers, etc. And there will be general purpose registers R1, R2, R3, R4, R5, R6, which store the data. By using those general purpose registers, we write the assembly language program. I will show you how it looked like assembly language program example. Some of you asked, right? Which we tell ALP in microprocessor and microcontroller.
So this assembly language we use in chip design as well, along with Verilog, system Verilog, and UVM.
No. That is only for processor.
Then what's the use case of this? So where do we use this?
That's
Assembly
what I'm
language?
telling. See, these are, see, first of all, what is meant by processor? It have do the instructions, it generate the instructions, it do arithmetic and logical instructions, right? That's what you told. The processor is controlling entire system, means that's what the instructions getting for the processor. This is what the instructions, if you see properly, observe here, there are a lot of instructions here. Equality operation is there, STA, LDA, jump operation is there, increment operation is there, some AND operation is there, arithmetic and logical operations is there. These all are complex codes which we run for processor instruction set. This is what the processor instructions. These instructions actually fetch from the memory. That's what the instructions we are going to design to control entire system on chip design. As you told, processor is the brain of the computer. Brain is nothing but it is generating the instructions. As you take the example of human. In the same way, brain is the processor is the brain of the computer. That means it generates lot of instructions. Those instructions we write in assembly language program. Here there will be a memory. Here there will be lot of instructions. Okay, there will be a program counter, which is a special purpose register, which fetch the instruction from the memory and send to the fetch stage. And then that instructions will go to the decode stage. That instruction will go to the execute stage. Decode stage means what? Suppose I am writing add R1, R2. This is what our human understandable language. See here example. These all are what our human understandable programming. Okay, to reset the things or to do the logical operation, to do the addition operation. This is human understandable language. But processor never understand this language. Right? Now, this language will be converted to binary. That means there are different types of operands and opcodes. Here there is a jump, STA, LDA. Okay. ASR, BCC. These all are different types of instructions like add, sub, multiplication, logical and logical order. Okay, now these instructions have a binary value. These instructions have a binary value. Every operand have a binary value. Every opcode had a binary value. Okay, if I show you more detailedly, suppose I am taking a immediate addressing mode in a RISC-V processor. See here, this is what exactly happens. In RISC-V processor, example I am taking processor architecture. See here, these all are different types of instruction. R type and register type, I immediate type, S type, SB type, U type, UJ type. Like that, these are different types of instruction set architecture. For different applications, different purposes, we use these instructions. Those instructions will be converted into the binary values because RS1, there will be related binary value. Function 7 have binary value. RS1 have binary value. Function 3. These are long concepts actually. So this entire instruction will be converted to the binary value in the decode stage, and even here arithmetic and logical operation execute stage, we do that execution, and here memory write stage and memory write back stage. This is it does one instruction execution. It takes these many stages to complete one instruction. Okay, example, MIPS processor is there. There is a RISC processor and also MIPS processor. MIPS processor is a like a starting stage if you want to learn. MIPS processor is nothing but millions instruction per second. That means in 1 second it is running million instructions. That is what MIPS processor. RISC processor, billion instructions it run per second. That is what exactly happening here. These millions of instructions can be run by the processor in these many stages. This is where we write the assembly language programming, and this is where we write the hardware architecture for this for this processor, whether it's a MIPS processor or RISC processor. Okay, and also here we follow the pipeline architecture where we can increase the speed of the operation. Tomorrow we will discuss about the pipeline architecture, and we will discuss more into the protocols, what exactly mean a protocol, because if you see, if there is no protocol, there is no communication between these circuits. This orange color, everything are protocols, different types of protocols. Okay, tomorrow we will discuss more detail. Is there any doubts for today's session?
What is this pipeline?
Tomorrow we will discuss about the pipeline. Okay.
Ma'am, is computer architecture and assembly language important if you have to get into VLSI industry?
No. That is totally different, not required. And also, we never use the system Verilog or UVM to do the verification for processor. We will discuss why tomorrow. System Verilog and UVM is used to do the verification only for hardware, not for processor cores. Okay.
Hello, ma'am.
Yeah, hello.
What is this core?
Ma'am, why the case size is
What
in
is the meaning of the
GB,
core?
not in a TB?
Sorry, hello. Please talk one person.
Cage
What is the
size
meaning of
is
core?
What is meant by a core? Core do the different task. One core will do 2 tasks. 2 cores will do 4 tasks. Like that. It runs a number of applications.
Okay. What is the architecture like inside? What it will have like cores?
Course is nothing but it's a total instructions. Instructions we need to write to perform those logical operations. It totally into instruction set architecture.
So it's not a hardware.
It's not a hardware.
Ma'am, a cage size is enough in a GB, not in a TB. Why, ma'am?
Case.
Cage.
Cache memory.
Yes, ma'am. Cache memory.
Because even in processors, cache is just to some extent in the processor. It is not total because processor will works at a gigahertz. It should not more than TB, right? It will be very costly if we use a TB. So that's why cache is we use only in the KBs, MBs only, not even in the GBs. Very rare.
Yes, ma'am. But the cage size is more. The application and processor is high speed, ma'am. That again, patching the information is easy to the previous ones and easy to move the multitasking like that.
Yeah, of course, it is easy, but because it doesn't require the TB. Why? Because not only cache memory, there are a lot of memories also, even RAM, ROM is there, hard disk also there in TBs. Main memories use GB, not only one cache, right? There are a lot of memories in a system. DDR memories will be there for data transfer.
Ma'am, another question for what is relationship between the core and the OS?
OS is a mediator. That means it connects the hardware and the software applications. Core is the totally hardware.
Yes, ma'am. But in
It's
a
like a
Mac like
processor.
that.
Core is nothing but a processor. Okay.
Can you summarize today's topics?
Yeah, sure, definitely. So today what we have discussed means, first of all, I have started with what is mean by VLSI. What are the different chips we have in VLSI, like from small scale integration, medium scale, large scale, ultra large scale. The technology, if you see from 2G mobile phone to 3G, 3G to 4G, 4G to 5G. Now how we are supporting the AI applications in a hardware level. Okay. And what is the main system on chip design? What are the functional blocks are there in system on chip design? Mainly what is meant by a processor, core, memories. These things we have discussed. Tomorrow we will be discussing more detail into the system on chip design and pipeline, non-pipeline architecture, and most importantly protocols. And also for especially for students who are looking for the job in VLSI, we have designed a course for protocols and the projects. It's a 2.5 week course. It is going to start from next week. If anyone interested to join can join here. There are 5 system on chip protocols in SV and UVM, and 2 major projects we are going to discuss. One is a RISC-V processor, another one is a DDR5 memory. The protocols are UART, I2C, APB, AHB, and AXI, from very scratch to till RTL design, SV verification, UVM verification you will be getting. For UART, total RTL design, I2C, APB, SV verification, with writing the test cases, coverage analysis, most important for VLSI verification engineers, and AHB-AXI in functional verification with the coverage and assertions you will be getting with VIP development. And RISC-V processor and DDR memory from very scratch to till RTL design and verification you will be getting. So it will be starting from today actually. So today and tomorrow I have planned for the demo sessions, because most of the people doesn't have the awareness on what is meant by protocol and what is meant by different projects need to learn in VLSI. That's why I have taken this 2 days session for the introduction, and from next week onwards we are going to start these projects and protocols. So if you want to learn, you can enroll for this course. And also the we have given the contact number here. You can inquire to this contact number. Okay. This is
Ma'am, is
what
it
the
free
total.
course or any money, ma'am?
It is not free course. It is not a free course. Obviously, most of the institutions are charging very high amount for these 5 protocols and 2 projects, but we are charging less price. We are charging 20,000 rupees for this course. Okay. And also we are teaching very good from scratch to till advanced. What exactly the interview questions will be asked from these projects and protocols, how you need to answer for the questions in interview. Definitely after these projects and protocols you will be cracking that interview in VLSI. Without these protocols your resume never select in any interview. So that's why especially for students we have planned this course. Okay. Mainly for projects and protocol, because system Verilog and UVM you can learn your own also, even from other training sources. But projects and protocols you never get in open source. Definitely you need to go for training, or you need to go with the seniors. So that's why especially for projects and protocols with advanced RISC-V processor, pipeline architecture, and DDR memory, we have planned 10 week. That means nearly 2.5 months, and this is what the detailed course curriculum. So you can go with this curriculum. If you want this detailed structure, we will share to you.
What is the example of course?
What?
Course, we were discussing about course, right? What are the examples of course in processor?
Examples of course, there is no example. Like even when you are buying the system, you will check, right? What is the processor speed? What is the core? How many cores are there? Whether it have 2 cores or 4 cores or 8 cores, quad core, octa core. You will check, right? Suppose if the laptop is i3 generation or i5 generation, i7 generation, you will check, right? That is nothing but the processor speed, the core, it depends.
Yeah, but what is that exactly about? Like, what is exact meaning?
Core in the sense it do multiple tasks. It run multiple tasks.
So it's a kind of program?
Yeah,
Code?
of course, it's an instruction set architecture which we use in a processor. Fetcher, decoder, executor. That is nothing but it will be done in CPU. That's what core. CPU have multiple cores. It do parallel tasking.
So that parallel thing, how it was possible? It is through some Python
here.
code or C code and
No,
anything.
no. It's not Python code. It's not C code. It's totally assembly language programming and Verilog HDL. See, here there is
do you provide tools for code verification?
Yes. See here, this is a CPU. You have a single core in your CPU, and there is another CPU. You have a multiple core in a CPU. One core means only one task it do at a time. If you observe old Pentium processors, if you see Intel processor, Pentium processor, those all are one core, single core CPU only. Multi-core means if there are more workload, it just do for number of tasks simultaneously. One core will run 2 tasks, 2 core will run 4 tasks, 3 core will run 6 tasks, like that. Quad core 4 tasks simultaneously. It runs more number of tasks. Nowadays whatever we are using, laptops, mobile phones, everything is multitasking. Hundreds of cores, hundreds of GPU processors are involving nowadays, because we are using everything servers nowadays. Server means very high speed processing is required, right? That all high performance cores. AI gaming processor use many cores. Even do you know ChatGPT? How many cores it is using? ChatGPT in main server, lakhs of graphic cores it is using in the main server in ChatGPT. How ChatGPT is working in every mobile phone, within seconds we are getting the data. How capable it is. Billions of phones are there, right? Every person is using ChatGPT. ChatGPT is not just not a software. It is having main server. In that server, it have lakhs of graphic processors, lakhs of cores in it. That's what processing speed.
One question. So this course specifically for student, and what about the experienced person? So basically, I'm working in embedded system, but I want to work in VLSI design. So for these kind of people, will this course work, or how it could be?
In VLSI, see, that's what RISC processor architecture we have designed in our course. This RISC-V architecture is a processor architecture which is nothing but a core. Processor is nothing but a core. Processor have instruction set architecture is nothing but a core. It do multiple tasking. Instruction set architecture run multiple tasks. That's nothing but a core.
No. Sorry, maybe you misunderstood my question. So I'm talking about
Caches
regarding
are
the
there in
course.
course.
The course you have listed, right,
Are the
for the
caches
students?
present in course?
What?
Caches are present in these cores?
Cache is separate, not in core. See, there is a processor. In processor, there will be cores and also cache. Cache will be not
The
there in
cache is not a
core.
component of core.
core. No. It is in processor. Processor have cores, cache memories, and different arithmetic and logic units like that. Yeah, someone girl is talking. Please tell.
Yeah. So this the provided course for some projects you mentioned, right? That specifically you designed the syllabus is designed for the student. What about the people working, the experienced people working? But I want to, yeah.
This course is applicable till 3 years.
Okay.
Till 3 years of in VLSI. If you have more than 3 years experience, I will suggest a PCI protocol. But you need to learn PCI protocol after completing these protocols only.
Okay. Okay.
Yeah.
Because I have 8 years of experience, so I
Okay.
want to switch my domain. So that is where I started. Yeah.
You want to switch embedded systems to VLSI?
Yes.
Then you need to start from scratch only. Verilog system, Verilog UVM, then these protocols and projects.
Okay.
You need to start as fresher only.
Yeah. Yes.
Okay.
Literally, these projects and protocols very helpful for you if you are looking for best resume and to crack the job in VLSI. You just never skip these. Okay, and also we are giving the training in very less budget with live sessions and recorded sessions, materials, assignments, everything will be provided. So if you want to enroll, you can listen tomorrow session also. If you are feeling good, then only you can enroll for the course. Okay.
Okay. Thank you.
Everyone, same link. If you are interested, can join tomorrow also. Embedded system engineers can switch into VLSI. IT people can switch into VLSI. Validation to VLSI. Anyone can switch because nowadays there are good opportunities. Most of the opportunities have for experienced people only, like who are switching. Yeah, and also switching is not much important. Like in which case you will get the best job means whenever you have proper skill set with the this practical experience with these projects and protocols. Whenever you have, then only you can crack the interview. Getting a job in VLSI is very not tough but not easy. Okay, so if you want to crack easily, you must have strong skill set with the projects and protocols. But once you get job in VLSI, next within 2 or 3 years, you will get very good hikes. At fresher level only, it is somewhat difficult to sustain.
Hi, ma'am. Could you please share the detailed curriculum for the course?
Yeah, sure. Can I share here? Just a second. Or even you can WhatsApp to this number. I'm sharing it in here. We'll share the brochure.
Okay.
Hello, ma'am.
Yeah.
You said we can't verify processor with SC or UVM. Then how we will verify?
You can join for the tomorrow session. I will explain you clearly.
Sure.
Okay.
Yeah.
Is there
Reminding.
any placement option is there?
Yes, we are giving the placement offer or placement assistance also. Actually, this is not placement guarantee program, but we have the placement collaboration with the companies. So we have the openings also. Actually, if we have best projects and protocol experience, we are providing the placements also for after these projects and protocols.
Okay.
Ma'am, I am in software domain. I want to switch to VLSI, and I have cleared many interviews. But then also I am facing to get job, get the job.
Did you clear the interviews?
Yes, ma'am. Yeah, AMD and Cadence I have given, but at last they say that you don't have relevant experience, so we can't take you.
Okay.
And after clearing interviews also,
once you share me your resume, I will try. Okay.
Okay, ma'am.
Please send your resume to this WhatsApp number. Another WhatsApp number is not working. Please everyone contact to this WhatsApp number only. Okay, any other doubts? Tomorrow also we can discuss at same time at 2 o'clock. Okay.
Ma'am, what is validation engineer?
Validation is also testing backend side. We do testing in backend. Okay, okay then. Thank you guys. We'll meet tomorrow. Okay.
Okay, thank you, ma'am. Okay, ma'am, thank you.
Thank you. Bye.
Thank you, ma'am.
Okay.
Thank you. Bye.
Thank you.